Hello everyone, my name is Dr. T.S. Kurne in Department of Statistics, Rajarshi Chhatrapati Shahu College, Kolhapur. In this lecture, we have discussed the points analysis of variance. The short form is ANOVA. The main purpose of this analysis of variance to test the homogeneity of the several means. In t-test, we have to test the homogeneity of two means. In ANOVA, it is used for the testing of homogeneity between the several means. The term analysis of variance was introduced by Professor R. A. Fisher, and the total variation in the set of numerical data due to the two causes. First is assignable cause and second is a chance cause. The variation due to the assignable cause can be estimated and can be detected and can be separated easily. But the causes due to the chance, which is beyond of human control, which cannot be estimated or cannot be detected or cannot be separated. So definition, according to the Professor R. A. Fisher, analysis of variance is the separation of variance ascribable to the one group of cause from the variance ascribable to the other group. The variance ANOVA consists in the estimation of amount of radiation due to the each of independent factors or causes separately, and then comparing these estimates due to the assignable factors or causes with the estimate due to the chance factor or causes, and the latter being known as the experimental error or simply error. So next is the Cochran theorem. By using this Cochran theorem, we have to use the analysis of variance. So let x1, x2, xn denotes the random samples from the normal population with mean 0 variance sigma square. Let's the sum of squares of these values written in the form of quadratic. So summation of xi square is equals to q1, q2, qk. This q1, q2 is the quadratic form of x1, x2, xn with the ranks, like there are degrees of freedom rj. J varies from 1 to k, and then the random variables which q1, q2, q are mutually independent, and the qj divided by sigma square is a chi-square variate with rj degrees of freedom. If and only if summation of ri is equal to n. So now we go for the one-way classification. Let us suppose that n observations yij I varies from 1 to k, j varies from 1 to n of the random variables y are the grouped on the sum basis into the k classes of sizes n1, n2, nk respectively, where this capital N is summation of ni as a given in the following table. These are the classes, kth classes, and these are the observation in each classes. This is the n1 observations from the first class, and t1 dot is the total of first class, y1 dot bar is the mean of first class. Similarly, the tk dot is the total of kth class, yk dot is the total of the kth class, and the total variation in the observations yj can be split into two components: the variation between the classes and the variation in the difference on the classification, and commonly known as the treatment, and the variation within the classes, that is the inherent variations of the random variables, and within the observations in the class. The first types of variation due to the assignable causes, which can be detected and can be estimated or can be controllable by the human endeavor. But the second type of variation is due to the chance, so it is beyond the control of human hand. And the main object of the analysis of variance techniques is to examine if there is any significant difference between the class means in the view of inherent variability within the separate classes. In particular, let us consider the effect of K treatment on the yield in the milk of n cows is divided into case classes of sizes n1, n2 up to nk respectively. Here n is equals to summation of ni. Here the sources of variations are: first is the effect of treatment, second is the error produced by numerous causes of such magnitude that they are not detected and identified with the knowledge that we have, and they together produced a variation random nature obeying Gaussian's normal law. And the assumptions are for the ANOVA test is the observations are independent, which is come from the normal, and the treatments and environmental effects are the additive in nature. Now we have go for the statistical analysis of CRD. First we write the statistical hypothesis. Hypothesis are mu1 mu2 h naught. Null hypothesis h naught is equals to mu1 mu2 mu v is equals to mu, and the treatment effects are like alpha 1 alpha 2 alpha v is equals to 0. So we know that expected value of mean sum of square due to the treatment is equals to sigma square under h naught. So expected value of mean sum of square equal to treatment is equal to expected value of mean sum of square due to the error is equals to sigma square. It is equal only in condition of under h naught. Otherwise, expected value of mean sum of square is greater due to the treatment is greater than the expected value of mean sum of square due to the error, because here some biased quantity is added here. Hence, the test statistics under h naught is provided the variance ratio. So f is the mean sum of square due to the treatment divided by mean sum of square due to the error. If the h naught is true, then the f should take only values 1, and otherwise it should be greater than the unity, because mean sum of square due to the treatment is greater than mean sum of square due to the error. So we have obtained the sampling distribution of statistics f defined in the equation 1 under h naught by Cochran theorem. The mean sum of square divided by sigma square and the mean sum of square are chi-square variates, and another chi-square variate is mean sum of square due to the error divided by sigma square. This both chi-square variates divided by its degrees of freedom take the ratio of those both chi-square variate is goes to the f distribution with v minus 1 n minus 1 degrees of freedom. So by simplification we get only mean sum of square error due to the treatment and mean sum of square due to the error. So if the calculated value or observed value are is greater than the tabulated value, then the degrees of freedom at the degrees of freedom at specified level of significance, then the h naught is rejected, otherwise accepted. And the above statistical analysis is simply presented in the following table, ANOVA table. So ANOVA table for the CRD is, in first row we have write the source of variation, second row their corresponding degrees of freedom, then third it is a sum of square, corresponding sum of square, like here two factors treatment and error, so the factor sum of square due to treatment and sum of square due to the error, and last is the sum of square due to the total. Corresponding here we have write mean sum of squares. So by dividing the sum of square to its degrees of freedom we get the mean sum of square, and lastly f ratio. F ratio is the ratio between ratio of treatment to the error. Thank you.